Here are the Chapter 3 answers. Pause the video, take a look, make sure you got them right, and we'll move along and start working them out one by one. Okay, question number 1. And 1 through 8 are all going to relate, so there's a purpose for them. We'll draw a timeline for each one. I want you to notice the differences, and that should help you realize what's going on inside your calculator. Question number 1, you want to know the value today. So with each one of these you need to draw a timeline. The timeline needs to be drawn well enough so that someone else could look at it and know when the cash flows occur and what you're looking for. So I'll put 0 year, that's today. Question mark, I'm looking for the value today, and I'm going to receive $1,000 per year for 20 years. Of course, I don't have to write down all 20 payments. I'll just skip down here to the end, put a little dotted line so know that I'm continuing to get that. Okay, so I need to know how many payments there are that's in, and there are 20 of them. I need to know what the payments are equal to. That's $1,000. I need to know the future value because the calculator is built to ask, is there anything else at the very last year besides the normal payment? The answer is no, so that's 0. So this term right here, these 3 are the payout rule. The interest rate is going to tell me something about my inflation expectations, my real rate of return, and any risk. So really you can think of these 3 as the size, timing of the cash flows, and this interest rate is the risk of the cash flows, which I have at 7%. So now that I have that information, plug that into my calculator, press the present value key, and here importantly, present value means one period before the payments start. So what this tool in the calculator does is take all of these payments and discounts them one at a time and moves them back to year 0. So the present value is actually the value in year 0, and that is $10,594.01. Now let's look at question number 2, and I will put number 2 right beside question number 1, or right underneath. I'm going to put it in red, and we're still asking the same question: what is the value today? But in this case, the payments start in year 5. So there's still 20 payments, because look how the question's worded. What is the value today of a money machine that will pay $1,000 per year for 20 years? And the next question you should ask is, when do the payments start? So they start in year 5. They start in year 5, and there are 20 of them. They will end in year 24. If you don't believe me, count it out on your fingers. So here I say n is equal to 20. Interest rate, payment. Payment is equal to 1,000. Future value is equal to 0. It's the exact same cash flows that I had before, and the interest rate is 7%. The only difference, the cash flows here start in year 5. You didn't tell the calculator when the cash flow started. The calculator assumes the cash flows start next year, so when you hit this present value key, it doesn't literally mean present value. It means it's taking all of these cash flows and moving them back to 1 year before the payment starts. So that's time 4. So here we have V4. And we're looking for V0. I know V0 is equal to V4 divided by 1.07 to the 4th. I know this from chapter 2. So I would recommend that before you pick your calculator up, you write all of this out, and then you can pick your calculator up and see that the value in year 4 is 10,594.01, the same number as here, because I have the same inputs, but I know that this really starts in year 5. The calculator sees 0 to 20. So the value today is equal to the 10,594.01 divided by 1.07 to the fourth, that is equal to $8,082.12. That's $8,082.12. Now let me move this up, not all the way, but just part of the way up, because what we have next, question number 3, I'll put here in purple, the exact same cash flows. So I'm not going to redraw this because they're the exact same cash flows. N is equal to 20. Payment is equal to 1,000. Future value is equal to 0. The only difference here is the interest rate is not equal to 9%, is not equal to 7%, it's equal to 9%. So these are riskier cash flows, we could say, because the interest rate is higher. So when I plug this in, it still, when I press the present value key, still gives me the value at year 4, because when did the payments start? The payments start in year 5, and that value is not 10,594. That value is going to be lower because the interest rate is higher. It's 9,128.55, and then the value today is the value in year 4 divided by 1.09 to the fourth, which is the 9,128.55 divided by 1.09 to the fourth, which is equal to 6,466.89. So question number 4 says, which machine is the most valuable? It's machine number 1, because the cash flows come sooner and the interest rate is lower. Okay, so let's look at question number 5. Number 5 is very similar to the previous ones. But in number 5, it says, I want to know the value today, but it's going to make payments every 6 months. So this is not 1 year, this is one period, 1 6-month period. This is 2 periods, which is 1 year, 3, and it's going to pay for 20 years. So it makes a total of 40 payments, and the payments are $500. So in this case, the total payments we receive are exactly the same, right? 40 times 500 is the same as 20 times 1,000. We both get $20,000. But here what we do is we say we have 40 payments. Those payments are 500. The future value, because there's nothing extra here, is 0. The interest rate was quoted as 7%, but when I say 7%, I mean 7% per year, unless I say something else specifically otherwise. So I take that 7%, and because it pays twice a year, I divide by 2, leave that as 3.5%. Now, you would rather have the money machine in number 5 than the money machine in number 1, correct? Because I'd rather have money sooner rather than later. So I press the present value key, and I realize that is the value today. That is what I'm looking for. That's going to be 10,677.54. So this is saying money machine 5 is more valuable than money machine 1, simply because it pays sooner at a faster rate. Okay, number 6, we make one twist on what happened in number 5. In number 6, we say, I want to know the value today, but the first payment is made in 5 years. Well, 5 years is 10 periods away because it pays every 6 months. So it pays $500 every 6 months for 20 years. So it goes from 10 to 49. You can count that out if you don't believe that that is 40 payments. So N is equal to 40. The payments are equal to 500. The future value is equal to 0. That's the payout rule. The interest rate is going to be 7 divided by 2, which is 3.5. I take all this, plug that into my calculator, ask for the present value. That gives me the value. You can't take the term literally. It doesn't mean the present value, it means the value one period before the payment start. The payment started in period 10, which is 5 years away. So that gives me the value in period 9. The value today is equal to the value in period 9 divided by 1 plus the interest rate, which is 3.5%, because this is 9 half years, not 9 years, to the 9th. So this should be 10,677.54, just like we had right here, because we put in the same information. But we didn't tell the calculator the payment started at period 10, so we have to make that adjustment ourselves. So the 10,677.54 over 1.035 to the 9th is equal to $7,834.44. Okay, now we'll work number 7. I'm not going to redraw the timeline because it's the exact same timeline. In number 7, it says that we're going to have the same payments, $500 a year, starting in period 10, going for 20 years. So N is equal to 40, payment is equal to 500, future value is equal to 0. It's the same payout rule, but here in number 7 we're going to say the interest rate is equal to 9%. I want to divide that by 2, so I'm really using 4.5. Plug this in, find the present value. When's the present value? Present value is in period 9, one period before the payments start. The interest rate went up from 3.5 to 4.5, so the value, the present value, should have gone down, and it did, to 9,200.79. So the value today is equal to the value in period 9, 9,279, divided by 1 plus R to the 9th. It takes, you start at time 0, you take 9 steps to get to time 9, and that value will be $6,191.25. Number 8, which machine is the most valuable? Number 5. Because number 5, they all pay the same amount of money, but some pay sooner rather than later. Some have a higher interest rate, some a lower interest rate. Lower interest rate is better. Let's think of that as lower risk. Sooner is better. So number 8 is the winner, and that's questions 1 through 8.